Hello everyone, let's look at today's Leetcode problem 3068. Find the maximum sum of node values. So this is a hard math problem, but before starting this problem, let us look at a motivational quote for today. Believe you can and you are halfway there. Theodore Roosevelt. I will leave it at that. So we always need to believe in our own self and we always need to trust in our own abilities and instincts. Okay, so let us understand the problem statement. So there are few things here. So there exists an undirected tree with n nodes numbered 0 to 0 to n minus 1. You are given a 0 index to the integers array edges of length n minus 0 to n minus 1 same length, and each edge will have a starting node and an ending node, and indicates that there is edge between nodes ui and vi in the tree. You are also given a positive integer k and a zero index array of non-negative integers. Non-negative integers nums of length n, where nums of I represents the value of node numbered I. Alice wants to sum of values of three nodes to be maximum, for which Alice can perform the following operation any number of times, including 0 on the tree. Choose the edge which has two nodes connecting U and V and update their values as follows. So nums of I, the first node and the second node can be XORed with the value k, the integer value k. This could be a positive integer. Return the maximum possible sum of values and less can achieve by performing the operation any number of times. Okay, so if we can understand maybe few of these examples that they have given here, maybe we can understand this problem. Yeah, so here if we see, we are having nums 1 to 1 and an integer k at 3, and we are given with value 0 node going to both 1 and 2 connecting. These are the edges, and each node has a value 1, 2, 1. So I hope this is what this means. So each edge 0 to 2, nums of 0 and nums of 2, 1 or 3, you can see, and nums. Okay. So yeah. So these are the edges which shows the connection between the nodes. So we have the node, uh, let's call this 0, 1, 2, and the node at 0 has a value let's see what the problem is achieving here. So n nodes numbered 0 to n minus 1, you are given edges for each node u of k, and so 0 to 1 and 0 to 2. So we are here to here, and these are undirected. Uh, this is an undirected, and the values of each node is, let's say, 0 starts with 1 and 2 and 1. Right? So Alice can achieve maximum value sum of 6 using single operation. So 0 to 2, 0 to 2, and XORing these two values, that is XOR one with the k value. There is nothing more than one XOR with the k value which is at 3 gives 2, and similarly one XOR with 3 gives 2. So if we do this, then this new value should be 2, and this already was 2, and this takes up a new value of 2. And if we remember the problem statements here, so we might choose an edge, and we definitely need to apply XOR operation to both of the nodes. And let's look at this example where k is 7. And there is one edge which says 0 to 1, and let's call this value 2 and 3. And XOR, let's say we XOR this value with 7. We get a value 4 here and 5 here. And this value is much greater than the value 2 plus 3. If we do not perform any XOR operations, we would initially have the value sum at 5. Once we XOR, we would be delivered with value 5 plus 4, which is equals to 9, and that's the output that we see. Right. So I think we've got a pretty good idea here, and let's look at this value. So here all of the nodes have the value 7. And if we XOR any of these values with 3, then we let's look at what the XOR operation really looks like. And 7 can be represented as 2 power 0, 2 power 1, 2 power 2, and 2 power 3. Right? So 2 power 2, 4, 2, and so this would be 1, 1, and 1. And if we will have to represent 3, then we might do it this way, where we might only end up with this is the value of 7 and 3, and XOR of this will give a result of 100, which is equivalent to 4, and 4. So doing XOR on each node would eventually give us 4, but if we do not perform any XOR operations, then we can use the value 7, which each node has as its initial value, and we would end up with 42 without the XOR operation. Right? So the understanding the XOR operation is the key thing here in this problem, and that's where our solution approach gets designed with. Right? So let's look at how we can approach this, how we can try solving this solution. So we know that as per the problem statement, we can XOR a specific edge, and edge might contain u of I and v of I, and we might need to XOR both of these values. That's this criteria, and we do that only if, and we calculate the gain only if the initial sum of node at u of I or say this as initial sum, and let's say the XOR gain, let's call this XOR sum. So we do this only if there is gain factor, or if the XOR sum value minus the initial sum is greater than 0. This indicates that the XOR sum value is obviously greater than the initial sum of the two node values, and then uh, it is meaningful for us to apply an XOR operation on a specific edge, which consists of two nodes. And that's where the core idea lies in. And from here, we will start designing a solution where let me start writing certain pieces where how we would design to our solution. So let's say we iterate nums, and we take each nums, and that would be a specific value of each node, and we do an XOR operation on this num value, num at I, and we perform XOR on this num value, num at I, and we see if it really can give a gain. So let's call this XOR value, and this is, or if this is obviously greater than the nums of I, then it would be meaningful for us to perform an XOR operation on this, and thereby calculating the sum on both of the nodes. So gain, and let's say total sum, which we only going to add up the gain factor plus the nums of I. If gain is greater than 0, so this would be our primary core algorithm, or the core logic in our entire solution. And we also can keep track of our min difference at each time, just so that we do not only apply XOR operations on odd number of nodes, so that we perform operations on even number of nodes. That's one thing. And let's we keep the minimum difference of the gain, so that we can subtract the minimum value just for the one piece of node. If it is an odd one, so that we subtract one piece of node to make it even, since we know that a specific edge will contain two nodes, right? So a starting node u of I and a v of I, right? So if we perform odd number of operations, and we uh, only perform the difference of a specific node which has a minimum gain, and we store that in a min difference variable. So that's the whole idea here, right? So I guess this makes an understanding. So let's quickly go to our Leetcode editor and try solving this problem. Now, initially we are going to set it to a large value with min difference, and as we progress or as we check the XOR values on each node, then we calculate the min difference at each point or each node. So I guess till here it's pretty much self-explanatory, where we calculate the total sum adding up with the gain only if the gain value is greater than 0, else we just simply consider the nums value or the node value. And we at each time whenever we add a specific XOR node gain value, then we also increase the count node, and at the end we but we might have to calculate minimum difference at each point, so let's do that. So this, as you can see, the solution gets submitted. And to understand the time and space complexity, we are only iterating through the nums array, and the space complexity is one, since we are not really having any data structure such as array or map or any sort of other things. So yeah, if you found this video helpful, please like and subscribe.